Hey y'all, this is OXDF, and today I am looking at server-side template injection, SSTI. We got the bolt box from HackTheBox, where we have a server-side template injection. We can solve this by going to PayloadsAllTheThings, grabbing a payload, throwing it in. We got execution, we're good, right? But this seemed like a good, kind of beyond root activity to dive in and look at the actual payloads. So we'll grab 3 different payloads from PayloadsAllTheThings, and we will look at each of them in a Python REPL. We will dive into the Jinja 2 source code a little bit, and we're going to understand how they work and what they're doing. So I think it's going to be fun, and I hope you enjoy it too. So with that, let's go ahead and dive in. All right, so let's start out with this is the PayloadsAllTheThings Jinja 2 remote code execution. So there's a handful of things here. For whatever reason, when I was solving Bolt, I skipped over this stuff entirely. We'll come back to that in a minute. And I was focused on this stuff. And I feel like there used to be a little bit more in this kind of relation, but really it was this payload I wanted to get working. And so let's take a look here. I'm going to copy this, and just looking at this by itself, it's like no idea what's going on, right? So let's dive into it a little bit. And we're going to go to a Python terminal. And we're going to paste that in. And let's go back a little bit here. In fact, let's go back really far. Let's go back to this. So we can start with this, and that is an empty string. So but that's not exciting, right? But if we do a dunder class, in Python, when we say dunder, if you say like dunder class, it means underscore underscore class underscore underscore. So and if we do dunder class on that, we get back that it's a class of string. What's important to note here is this is not printing a message saying that it's not like a string message saying it's a string. It is actually the string class, or it's the string type. I believe if we do a type on this, so it's actually going to return a type, and not so it's a type class. But it's literally a pointer to that. So if we come here and we do like a dir on this, we have access to all these different things, these methods, and different parameters associated with the class. And so we can do, what can we do with that? Well, get rid of this, get rid of that, let's go back again. We're going to call MRO on it. And so what on earth is MRO? That's interesting. Let's come over here and, we have Google, we have Stack Overflow here to help us. What does MRO do? And the answer is it has to do with inheritance of class types. And so, for example, here, if you have class A that's like a object, and then we call MRO on it, it's going to return this A, and then it's going to return object. And if we have B that is subclass on A, you're going to get B, A object, etc. C, A object. And so what this allows us to do is, I'm not really sure the legitimate use for this at the moment, but what we're looking at specifically is we can now get an object. So if we can get like one of that, now we have the object. So what can we do with that? Well, we're going to call subclasses on it. Get all the subclasses of object. Oops, I should get rid of that in my paste. So we get the big list of things, right? And so if we go back and look at the payload all the things, we are now they're going to grab 396. So if we grab 396, actually out of range, we're going to say, okay, well, how can we like look over all these different classes that came out of here? And so one thing I thought was like, we know we're going for subprocess.popen. So if we do x for x in, if subprocess in string of x. And here we go. So we get back within this long list of things, there's subprocess, completed process, and subprocess popen. And so if we do that and get the first object there, we can see this is actually like the subprocess popen function, and with that function we have all the things we need to, we can call it. But we need to know where it actually falls, right? So we saw that it is in here. We want to do, let's see, maybe what we can do here is enumerate. What that's going to do is, instead of x is now going to be a tuple that is the number, the offset into subclasses as well as the value itself. And it would help if I close my parentheses somewhere. Do I not need that? Yeah, cool. So it's 242. Let's go back up here and make this 242. And now we have subprocess.popen. And so now we can do things like make this 242. And we don't have a flat like that text, but we can do a, who am I? And there we go. We're OXDF. So we have command execution here. Now there's one little trick here that I kind of skipped through that I didn't realize until I started playing with this. What's interesting here is if I make this call right now, it's going to fail. And if I make it again, it succeeds. And the reason, this is actually kind of interesting. Let's get out of here and come back again. If I do len of, let's get the subclasses here. So if I do the length of the number of subclasses, it's 181. Now when I make it fail, and now I look at the length, it's now 618. So it actually is happening as Python is doing stuff in this kind of global space within the environment, the subclasses it's aware of actually increases, and there's more of them. And so it's interesting that within this little environment, the environment of this Python process, when I first start, I only have 181 objects in the subclasses of object. But as soon as I cause a crash, now there's 618. I'm sure this payload right here is relying on the fact that we know something about how Jinja 2 is working within Python, that subprocess.popen will always be there. But again, that's why they may load in different orders and may load in different places, because it's a little bit more variable than that. So what we can do, if we want, let's see, so we can come in here and get all, let's say we want to find all the subclasses. Let's grab that. And we'll jump back into, this is actually where the SSTI is. We'll put that in here. We'll submit. I can actually, let's see, close that. Refresh. I got an email. We confirm the changes. We go back, we refresh, we get another email. And, oh, we didn't run. I'm willing to bet. Let's see, we paste this in and we need to put it in squigglies like that. Submit that again. Refresh. Accept. Get rid of the old one. Refresh again. And here we go. We now have the output of the SSTI and all of these things. We can, let's see, we can do a little bit of like, let's grab all this. Got it. Okay, if we grab all this and we go back into our terminal and we vim objects, paste this in. We now have all that. We can cat objects into tr. We'll place that with a new line. And let's make sure that worked. It looks good. And now we will grep subprocess. And we will grep -n. And so we can see right here, the popen is actually 223 in the environment that Jinja 2 is running out on Bolt. And if we do that, let's see, if we do head objects, oop, that's not what I wanted to do. If we do a grep -n on type, we'll see that it actually is 1. It starts at 1. So that's important because that means when I go to do it on Bolt itself, if I'm going to be 0 based, which is what Python is, this is actually 222. So I would want to put 222 in there and go with that. There's actually another payload on here. Let's see, go back here. That tries to do all this for us. And we're going to actually do a loop here. Let's see, let's grab this real quick and we can copy. Look at that. Come back here and we do vim payload 2, paste this in. Now this is doing a loop within the templating engine. So basically this right here says I'm going to loop over all of those subclasses, same as we just saw. if warning is in x.name, within the name subclass, then we're going to do all of this. Now, most of this is just getting a reverse shell. It looks like it actually, we're writing. I'm not really sure why we're doing all of that, but let's see. The part we care about is getting to popen. So we're going to, oh no, we're getting to the built-in /import. So let's play with this a little bit. Python. So we get our subclasses again. It's interesting. This time it starts with this. If I do type on that, it's actually a tuple. So we're starting with tuples this time, but similar, same idea, right? We're going to get the class and then the base. Let's see what that does. So we're back to, this is all just another way to get to object. Now we can do .dunder subclasses like that, and we get a lot of stuff. And so what are we going to do this time? So now they're going to do literally what we just did. So they're going to do x for x in, and we're going to do it in Python. So we're doing it in a list comprehension. And they're going to say if warning is in x.name. If warning in x.dunder name. And what do we get back? We get catch warnings. So we'll get that object out. And then what are we going to do with that object? We're going to actually call it, it looks like. Okay, it looks like it returns a function. And we'll kind of single underscore. Not sure exactly what that is. Okay, we got a module though. Dot underscore built-ins underscore. So that is this is returned a lot. It looks like it's a dictionary. So we can do keys here, and this will show us all the keys that came with that. And what they're taking advantage of here, where did I? Oh, it's up in the top window here. Let's make this bigger. Built-ins. So they're now using that. Let's see, where were we? Instead of saying keys here, we will do underscore import. That, and that now we've got a hold of the import function, which is useful, right? So, and once we have that, we can do OS, and now we have the OS module, and now we can do popen like that, and now we have the popen function. So it's another way now to do that, such that we're again trying to like use this clever way to sort of start off with things we know will be there. In this case, like an empty tuple, and work our way back to the point where we can guarantee that we have got a hold of this OS popen function. So that's kind of neat. The other thing I wanted to look at is these up here, because these are much simpler. In fact, we can, for the sake of just showing, we come over here, we put that into name. I went through all that work in my originally solving it, and as I'm sitting here doing the write-up and kind of checking on it, I'm looking at it and going, why didn't I use these simpler looking payloads? I wonder if they work. And I came over here and put it in, and let's refresh. Please confirm your changes. We're going to confirm our changes. We're going to get a new email, and it worked just like that. Like all I had to do was copy it off the web page and put it in. So what are they doing here? Let's take a look at these a little bit closer too. You can see these things: namespace, joiner, cycler. There's longer versions up here where we're actually using the templates reference context to get those same objects. These are not standard Python things. If I come over here and put this in here, right, cycler is not defined. So we're going to need to actually go dive into the actual source for Jinja to get a feel for what this is doing here. So let's see, we can do Jinja to source. I think it's on GitHub. Yep, here we go. And let's do a search for namespace. Picked any of these, but that seems like a good place to start. And ooh, the internet is going slow today. That's not what I expected. I wonder, is it capitalized in here? Okay, here we go. Namespace, so we have defaults. Let's go ahead and dive in here. Oh, so from utils import namespace. Let's see, so there's a namespace. Jump over into utils. So, and here's the namespace object. That all looks fine. I think actually before I go into this, let's stop here for a second. We're gonna come back to this. The next thing we need to look at though is, let's open up a new one here, and we will do a vim of test.py. And we've already got a test.py. That remove test.py, vim test.py. Abort, remove test.py swap. Okay. Let's do a vim on class.py. And in here, we're going to do something like, we're going to import OS, and then we're going to make a class, test class, and it's going to, it needs an init. We got to def init, take self, and we will just pass and do nothing. This is the dumbest class that ever existed. If we come down here now and go into Python, move that up a little, and we do from, what I call it, class, import test class. What I called this? That's not right. Why is that not working? Oh, I bet class is a well-defined thing. Let's see, move class to oxdf.py. Move class.py. Then that. Okay, now can we from oxdf import test class? Yes. So we have test class. Cool. So let's take a look at what they were doing here with this thing. So they are getting the init function. So we have test class dot under init, that actually is the function. You can see it's a function. That actually is the function that comes with the init. And why is that useful? Well, if we do now under globals, I think I like that. Now we have access to all the globals accessible to that function. And that is useful because it's also going to include, let's do dot keys to just show the keys because it's a dictionary. We've got the OS module right here, and that's because we imported that. If I came back up here and instead of, and if let's say I remove this, go back out, Python, import my class, look at my keys, you'll see OS isn't there anymore. So whatever this class is importing into its globals, the globals object here is going to have access to it, whatever is important, available within this file here. So that's important because now we go back here and we say, oh, so if we can get a hold of one of these namespace objects, well, when we get to any function within it and then the globals, now we get access to all of this stuff. And so it just so happens when I have the OS module, I've now got execution. So, so I can come in here and say OS. I think they do? I think they do popen, but I'll do system ID because we're in my modified version. Undo. Import. And here we go. So now you got the output of the ID command. And that is because we've tapped into this Python object. We've pulled out its init function, which we could, I think, let's see, we can probably do this with any other function too. There's going to be, does that work? No, that didn't work. Okay. I wonder if we have to define the function. So if we come down here, def test self pass. Get out of here. Come on, import that. And so now, test. Yeah, so that still works. So basically, as long as we can get a hold of any function that is within this method, as long as we can get a hold of any function, we can now get the globals object and then pull out whatever imports it has available to it. And so because we know that this function right here has imports of OS, we can now abuse that. So I can't just, I could, we could do this real quick. I could grab this utils.py because it doesn't look like it's importing anything else. So let's do that. If we come up here and we wget that, and now if I do from utils import namespace, I believe it was, So I can do the same thing with namespace that I did before. Where was my, there we go. That works. I can also do things like if I do namespace equals namespace. So if I get an, so right now, capital namespace is the class. If I do that, now namespace lowercase namespace is an object from the class. Oh, that doesn't work. We don't get the init that way. I wonder if we can get, let's see, what was, ooh, raw is hard to read. Namespace. What's a thing within, so REPR is in there? No, it doesn't work. Okay. Does it work in capital? It does. Okay, so you have to, it looks like we need to get a hold of the class itself, not an instance. Now, if you're a really astute observer here, you might be noticing, hey, like there's two differences that they tried from what they were doing, what I was doing. One, they're reaching lowercase namespace. It's not immediately clear how, what that is. It's possible that something, somehow in the way it's getting loaded up within the Jinja environment, that's just coming out that way. The other thing is they're calling .os. I'm not sure why that works that way. So they are doing basically that, and that doesn't work here because I'm getting a dictionary back. That could be something with how the templating handles dictionaries, and that it just allows for dot pulling out dot key to give you a value. Not totally sure, but anyway, I think in general we have the point of what this is trying to do. So yeah, I think I'm gonna call it there. That's three different. We've looked at three different Python server-side template injection here today. Tried to understand how they work and what's going on. So hopefully you enjoyed this, and if you're one of the few people who stick around till the end of the video, thank you so much. I really appreciate it, and I will talk to you next time.